All right, so we are moving on to objective 3 here. This objective is called literal equations, and so we are going to be solving for variables in this objective. It is going to be probably the most challenging objective you're going to see, so make sure you're really taking the time to listen as I'm going through each of these examples. So let's start with some basic examples. Hopefully these should be a review of just solving basic equations. So looking at example 1, we have 5 plus y equals 12, and I want to solve for y. So if I want to solve for y in this example, remember inverse operations, I want to subtract 5 from each side of that equals sign. So hopefully this should be a review. If I do that, 5 minus 5 is going to cancel out, and I'm left with y equals 7. So we're just using those inverse operations to isolate the variable y. Let's do one more review. So for number 2, I want to solve for w. So in this example, I have division, w divided by 8. So the inverse operation of division, the opposite of division, is multiplication. So I want to multiply both sides of the equation by 8. Remember, whatever you do to one side, you have to do to the other side. So once I do that, this is going to cancel out, and I'm left with w equals 72. So that should be a little bit of review on just inverse operations. Now we're going to move on to examples where there might not be as many numbers, there might just be letters involved. So these are some definitely different examples, things you haven't seen before. So let's look at number 3, sorry. Number 3 is very similar to what we did in number 1. So this one asked us to solve for x. So I like to put a little box around the one I'm trying to solve for. That's the one I want to try to get by itself. What that means, if I want to get it by itself, I want to move everything over to the other side of the equation to get x by itself. So very similar to what we did in number 1, I have plus b here. I want to subtract b from both sides of this equals sign. So I'll go over that one more time. Because I want to get rid of that plus b, I'm going to subtract b from both sides of the equal sign, just like it did in example 1 where I subtracted 5 from both sides. So once I do that, this is going to cancel out, and I'm left with x on this side, which is good. I want to solve for x. I want to get the x by itself. Well, let's look here. I have a minus b. Remember back to the simplifying algebraic expressions unit. Are these like terms? No, they are not. They are not like terms. So I cannot combine them. I just stick them right next to each other. A minus b, this is my final answer. So really I'm not solving anything necessarily. I'm just kind of moving things around to get that variable by itself that I'm looking for. In this instance, I was wanting to get the x by itself. I asked for the x, so I got that x by itself, and so my final answer is just x equals a minus b. All right, so let's do another example. Example 4, we have solve for d. So I'm going to zoom in here. So it says solve for d, and we have CD equals 10. So I'm going to go ahead and put my box around that d. That's the one I'm solving for. I want to get that one by itself. So remember, back to our units, when you have two variables next to each other, that is multiplication. So this operation right here is multiplication. So I'm going to divide both sides by c to get rid of that c. The opposite of multiplication is division, so I need to divide both sides by c. That can cancel out the c here. We are left with just d on one side. That's good because that's what I'm trying to solve for. And then 10 divided by c, I can't actually do that, right? I can't actually divide those. So I'm just going to leave it as 10 over c, and that's my final answer. So for these types of examples, we are not actually solving for a number. We are just moving things around in the equation to get that variable by itself. All right, so we're going to try a few more examples together, and then you're going to try a few on your own as well. So let's look at number 5. So in this one, it says we want to solve for k. So I have to solve for k. So I'm going to put my box around k. That's the one I'm trying to get by itself. And I want to move everything over to the other side of the equation except for that k. So this one's going to take a couple steps. The first thing I want to move over, let's say I had something like 3 minus k equals 10. The first thing I would do in this equation is I would subtract 3 from both sides of the equal sign. And then I'm left with negative k equals 7. So in our example here, I'm going to do something similar. I'm going to subtract p from both sides of that equation. So p minus p is going to cancel out, and I'm just left with negative k equals, r and p are not like terms. Those are not the same letter. So I can't actually combine those. So I'm going to do r minus p and just stick them right next to each other. Well, looking back to our number example over here on the right-hand side, look in here, I still need to get k by itself. So this negative is the same thing as negative 1. I'm going to divide both sides of the equation by negative 1. That will get rid of that negative 1 on this side, and I'm just left with k equals negative 7. I want to do the same exact thing for the one we're actually working with. I'm going to divide this side by negative 1, right? Whatever I do to one side, I have to do to the other side. So I'm going to divide each of these by negative 1 as well. So this is going to cancel out. I'm just left with k on this side. R divided by negative 1 is just going to be a negative r. It's basically just going to flip the sign. Negative p divided by negative 1 is just going to be a positive p. So when I divide everything by negative 1, it's just going to cancel out all of the negatives, basically flip the signs there. So this would be my final answer. Again, just like the first couple, going back to those examples, I'm not actually solving for a number here. I'm just moving things around to get that variable by itself. So in this example, it said solve for k. Well, once I have that k by itself, I know I am done with the problem. You are not done with the problem until it's completely by itself. There can't be anything next to it. Let's look at number 6. Number 6 is very similar to our example we did with the numbers, right? So looking at this example, it says solve for v. So in this one, I have v over b equals j. And I'm going to go ahead and put my box around the v. That's the one I'm trying to solve for. So going back to our example here, we multiplied both sides of the equation by 8 to get rid of the 8 on the bottom of that. We want to do the same thing for number 6. So I'm going to multiply both sides of the equal sign by b to get rid of that b on the bottom, because the opposite of division is multiplication. So this cancels out. I'm left with v equals j times b is just going to be jb, and I'm good to go because remember, as soon as you have this variable by itself, we're trying to solve for v, I have it by itself, I am done. All right, so that is some examples of literal equations, some one-step ones, 2-step one for that. We're going to go over a couple more examples on the bottom. So now we're going to get a little bit more difficult, maybe a couple more steps. So let's remember, if we're solving for this y, this is a 2-step equation. So I'm going to draw my line down the equal sign. I want to solve for y, get this y by itself. So I'm going to first subtract 4 from each side of the equal sign. Once I do that, I'm left with 2y equals negative 10 minus 4 is negative 14. I still want to get this y by itself. So I still have to divide both sides by 2 to get rid of that 2 next to it. So my final answer would be y equals negative 7. We're using those inverse operations to solve for y. I'm going to do the same thing when I have just letters, when I have these literal equations. So in number 8, it asks us to solve for m. So I'm going to leave example 7 up here so you can kind of look at it and use the same methods we've been using. So I want to solve for m. So the first thing I'm going to do is I'm going to put my box around that m. That is what I'm trying to solve for. So the first step I did is I subtracted 4 from both sides up here in number 7. In example 8, I want to get rid of that minus p first. So I want to add p to both sides. So when I do that, negative p plus p is going to cancel itself out, and I'm left with 2m equals, let's think about this, 11 plus p. Those are not like terms. Super important. I can't actually combine them. So I'm just going to write it out as 11 plus p. I'm just moving it over. Well, I still want to get this m by itself. So I still need to get rid of that 2 next to it. I can't stop the problem until that m is by itself. So I'm going to divide every single thing by 2. So divide this guy by 2, this guy by 2, this guy by 2. This cancels out, and I'm left with m. That's good, right? That's what I'm trying to get by itself, equals 11 over 2 plus p over 2. That does not simplify, so I just keep it like that. And I know I'm done with the problem because it says to solve for m. I have m by itself right here, so my final answer would just be this. So let's try one more, and then I'm going to have you do a couple on your own. So let's try actually number 10. For number 10, I want to solve for h. So I'm going to zoom in here. I'm going to put a box around my h. That's the one I'm trying to solve for. That's the one I want to get by itself. So let's go over a similar problem just with numbers. Let's say I had the equation 12 equals 3h over 2. So for that problem, I would want to get rid of that 2 on the bottom first. So I would multiply both sides by 2. So then I'm left with 24 equals 3h. I'm going to do the same exact thing for the problem we are working with here. I'm going to multiply both sides of the equal sign by 2. This is going to cancel out the bottom here. Well, 2 times a, I can't actually do that, so I'm just going to leave this as 2a equals bh. I'm going to put that box around it again, because again, I'm still solving for the h. Still want to get the h by itself. So let's go back to our other example we have on the right. Well, my last step here is I want to divide both sides of the equal sign by 3. If I do that, I'm left with just h here equals 8, and that would be my final answer. So let's think to this problem here that we have. So if I have BH equals 2A, I want to get that H by itself. So I'm going to do something similar. If I want to get rid of that B, this is multiplication, I'm going to divide both sides of the equal sign by B. That would get rid of that B on this side, and I'm just left with H equals 2A over B. I cannot do anything else. So again, it says to solve for H. I have this H by itself. I am done. It's very similar to just solving normal equations. The only big difference is, right, you're not actually getting a number. You're just moving things over and getting that variable by itself. All right, so I want you to pause the video right now and try numbers 9 and 11 on your own, and then we will go over those answers in just a moment. Pause the video, actually try them. All right, so let's go ahead and take a look at numbers 9 and 11. So hopefully you paused the video and actually tried those on your own. Let's check our answers. Number 9, we are trying to solve for b. So we're trying to get this b by itself right here. Okay, so the first thing I did is I subtracted pH from both sides. Remember, when you are solving an equation, you want to do opposite of order of operations. So you want to add and subtract first. So I move that over. And then I'm still trying to solve for b, so I still got to get that b by itself. So I divided both sides by 2 as my last step. And my final answer was b equals s minus pH over 2. So that is number 9. Number 11, I'm trying to solve for L. Trying to get this L by itself right here. So the first thing I did is I added b to both sides. Well, remember, a and b are not like terms, so I just have a plus b there. I'm still trying to solve for L, so I have to divide both sides by m so that these can cancel out here. And I'm just left with L equals a plus b over m. And so that is literal equations. It is a very challenging concept. It is weird. You're not actually solving for numbers, right? There's just a bunch of letters and we're moving them around, right? But it's very similar to what we've already been doing when solving equations. Okay, so always think back to what's the next step I would do if these were numbers. That'll help you out. All right, so you should be moving on to your choice activity and objective quiz for today.